Let's do section 10.3, page 504, exercise 13, which reads, find a formula for the truncation error if we use the partial sum P6 of x to approximate the function 1 over 1 minus 2x on the interval from negative 1/2 to positive 1/2. Now, the first thing we need to recognize is that that is a geometric series with a equal to 1 and r equal to 2x. And because the interval is from negative 1/2 to positive 1/2, this is going to converge. So we can write out f of x, which is going to be equal to 1 over 1 minus 2x. And we can write out the terms of our geometric series. So we're going to have 1 plus 2x plus 2x squared plus 2x cubed plus 2x to the 4th plus 2x to the 5th plus 2x to the 6th plus 2x to the 7th plus 2x to the 8th, and then this series just keeps going. Now we are interested in this partial sum, which is going to be the terms out to k equals 6. So this is going to be P6 of x. And the truncation error is going to be all the terms that are left over. So we could say that the truncation error was that absolute value of f of x minus, in this case, P6 of x. And that's just going to be the terms that are left over. So that's going to give us 2x to the 7th plus 2x to the 8th plus 2x to the 9th, and then of course that just keeps going. Now we're supposed to find a formula for this, and let's just label this as the truncation error. We're supposed to find a formula for this, and let's see if we can play around with it a little bit. So one of the first things that we might want to do here is factor out a 2x to the 7th, and then we're going to be left with 1 plus 2x plus 2x squared, and that is of course just going to continue out to infinity. But we already know what that is. What is it? Well, it's the geometric series that we began with, and it's equal to 1 over 1 minus 2x. So we can write our truncation error as the absolute value of 2x to the 7th over 1 minus 2x. And if we want, we can just kind of clean it up a little bit here. And we've got 2 times the absolute value of x, that whole thing raised to the 7th power. And we can remove the absolute value signs from the denominator because we know that for all x in this interval, negative 1/2 to positive 1/2, that 1 minus 2x is going to be greater than 0. So this is going to be, again, our truncation error. And that is what we were trying to solve for.